Hi everyone, welcome back to Prakasham Tutorials. In this video, I am going to discuss about one more example of the PTSP problem. So this is a previous examination question. So the given example is a binary symmetric channel is shown in below, and this is a binary symmetric channel. Find the probability of A1, probability of A2, probability of B1 by A1, probability of B2 by A2, probability of B1 by A2, probability of B2 by A1. So coming to the solution, and this is the given binary symmetric channel. From this symmetric channel, let the event B1 is the transmitting a 0 bit, event B2 is the transmitting a 1 bit, and event A1 be the receiving a 0 bit, and event A2 be the transmitting a 1 bit. So the conditional probabilities are so given that the probability of transmitting a 0 bit, the probability of transmitting a 0 bit is P of B1 is 0.6, and the probability of transmitting a 1 bit probability is 0.42, and also okay, find out the probability of receiving a 0 bit, find out the probability of a receiving a 1 bit, and also given that the conditional probabilities from that figure, the probability of receiving a 0 bit when 0 bit is transmitted, that is P of A1 by B1 probability is 0.9. The probability of receiving a 1 bit when 1 bit is transmitted, that is P of A2 by B2 is 0.92. The probability of receiving a 0 bit when a 1 bit is transmitted, that is P of A1 by B2 is 0.1. The probability of receiving a 1 bit when a 0 bit is transmitted, that is P of A2 by B1 is 0.1. So these are the conditional probabilities from the given binary symmetric channels. The last two conditional probabilities, that is P of A1 by B2, P of A2 by B1 are the P of A1 by B2, P of A2 by B1 are error probabilities at the transmitter. Since A1 and A2, A1 is the receiving a 0 bit, A2 is the receiving a 1 bit. Since A1 and A2 are mutually exclusive events, using total probability theorem, the probability of receiving a 0 bit is probability of A1 is equal probability of A1 is equal using total probability concept. P of A1 is equal P of A1 by B1 into P of B1 plus P of A1 by B2 into P of B2. From the given data, P of A1 by B1, P of A1 by B2, P of B1, P of B2 are there. And substitute all the values into this equation, we get the probability of receiving a 0 bit is 0.58. So similarly, the probability of receiving a 1 bit is P of A2 is using total probability. P of A2 is equal P of A2 by B1, P of B1 plus P of A2 by B2 into P of B2. From the given that all the values are there and substitute all the values into RHS term of this equation, we get the probability of receiving a 1 bit is 0.42. And after that, we can determine the probability using Bayes theorem, the probability of transmitting a 0 bit when 0 bit is already received. So that is using Bayes theorem, the probability of transmitting a 0 bit when 0 bit is received. So that is P of P1 by A1. Using Bayes theorem, P of B1 by A1 is P of B1 into P of A1 by B1 by P of A1. From the given data, P of B1 is there, P of A1 by B1 is there, and here P of A1 is calculated. Substitute all these values into RHS term of this equation, and after that reducing, finally we get the probability of transmitting a 0 bit when a 0 bit is received is 0.931. Next, determine the probability of transmitting a 1 bit when a 1 bit is already received. So that is probability of B2 by A2. So using Bayes theorem, P of B2 by A2 is P of B2 into P of A2 by B2 divided by P of A2. And substitute P of B2, P of A2 by B2, P of A2 values into RHS term of this equation, we get 0.857. So this is the value of the transmitting a 1 bit when 1 bit is already received. Next, determine the probability of transmitting a 0 bit when a 1 bit is already received. That is P of B1 by A2. So using Bayes theorem, P of B1 by A2 is P of B1 into P of A2 by B1 divided by P of A2, and substitute P of B1, P of A2 by B1, P of A2 values into RHS term of this equation, we get P of A1 by B2 is, P of B1 by A2 is 0.142. And finally calculate the probability of transmitting a 1 bit when 0 bit is already received, that is denoted by symbolically P of B2 by A1. Using Bayes theorem, P of B2 by A1 is P of B2 into P of A1 by B2 divided by P of A1. And substitute P of B2, P of A1, P of A1 by B2 on RHS term of this equation, we get 0.068. The last two conditional probabilities, that is P of B1 by A2, P of B2 by A1, are the error probabilities at the receiver. And this is the example of the Bayes theorem.